In section 1.4, we're going to be looking at compositions of functions. I want you to pause the video and write these down because these are the ones that you're going to be working with. Now that you've done that, you have got an addition, a subtraction. The biggest thing I can tell you about the subtraction is this parenthesis set. There's a homework question that you're going to see on a quiz, and that's generally something that we like to leave off, but you have to distribute that negative symbol. When you are multiplying them, that's just side by side multiplication and then division. And then with composition, those are the ones where you substitute one into the other. So we're going to start with the compositions. The addition, subtraction, multiplication, and division, I'm not going to spend a whole lot of time with because you've done those since Algebra 1. If you're working on that homework and you have a question, I will be more than happy to help you, but it seems to be that it's these f of g of x that we have trouble with. So I'm going to start here. So with these questions, what you're going to do is be looking from the inside out. So I'm going to substitute a 0 into the g function. So I'm going to be substituting a 0 in right here. Now the f that's out front is still there. So this is f of, and then I have 7 minus 0, and I square that. So this is f of 7 minus 0, which is just f of 7. So now I'm transitioning to where I'm going to put the 7 in where this x is, because that's the f function. So this is going to be equal to 6 times 7 minus 8. So I got 42 minus 8, and that's going to give me 34. And that would be my typed in answer. So if I go in the opposite direction, it works exactly the opposite way. So this is an f of 0, so I'm plugging that in right here. The g that's out front is still there because I have not yet evaluated. So if I plug this in, I have 6 times 0 minus 8. So this is going to give me g of 0 minus 8, which is negative 8. And then I'm adjusting to where I'm going to plug this negative 8 in where this x is. So I'm going to have 7 minus a negative 8, and that negative 8 is squared. So I have 7 minus, now when I do negative 8 times negative 8, I get 64. And then 7 minus 64 is negative 57. And that would be your answer. The next example is giving you a table where the first column are your domain values, so those go 0 to 9. The middle is the y value if you would have been evaluating in the f of x function. And then the third column is what you would get for each domain value if you were evaluating in the g of x function. So these questions tend to be fairly easy for kids to understand as I walk you through them, and then they tell me that when they get into it on their own that they end up being confused. So I'm going to walk through every single one of these very slowly. First thing I'm going to talk about is the fact that we are going from the inside out. So the f that's out front is still there. So now I'm looking for a domain value of 4, and I'm looking for what the y value is in the g function. So this is f of 9. And then I reset myself because I'm starting that over again. And this time I'm looking at a domain value of 9, and I'm trying to figure out what the y value would be if I evaluate that. And that will give me the number 2. So we're going to move on to the next one. We have f of 2. So I'm looking at a domain value of 2, and I want the f function, so that gives me a 5. The g that's out front is still there because I haven't evaluated that yet, which is what I do next. So I reset these, and now I'm looking at a domain value of 5, and I need to know what g of 5 results in, and that would be the number 0. Then I reset again for the next question. We are looking at f of 3. Now the front f is still there, so these are like f composed with f. So I'm looking at a domain value of 3. I want to go to the f function, so that gives me the number 9. Then I reset that, and now I'm looking at a domain value of 9, and I'm still at the f function. So my answer this time will be a 2. And the last one in this one, I have g of 7. Resetting that. G of 7. Oh, sorry about that. G of 7 gives me a 0. So that is, the front g is still there. I'm evaluating at 0. So g of 0, I go up here, and g gives me the number 4. So walk through those, write them out slowly but surely as you go. Start from the inside and work out, and don't erase your table like I did. So this question is asking the exact same thing. The graph on the left is your f of x function. The graph on the right is your g of x function, and they are asking you to do the same thing. It's just that you don't have a table to go by. So we're going to work these out the same way. So we start on the inside. I have g of 5. So what I'm looking at is on the right-hand function. I know that that's g. I'm looking at a domain of 5, and then the y value that I would have at that ordered pair point is here. So that would be 3. So the front f is still there. G of 5 gives you the number 3. And then when you do f of 3, I come to the other side. And at the other side, I'm looking at a domain value of 3. And the ordered pair point that goes with that is up. And that will give me a final answer of the number 5. So now I'm going to reset these ordered pair points and shadings, if it'll let me without erasing the graphs. There we go. All right, so I'm going to start over again. We are looking at the next question. So I want f of 4. So I'm looking at the f function, so that's this one. And I go up, and the ordered pair point that goes there is 3. So the front g is still there. I'm evaluating it at an x value of 3. So now I'm going over, and I'm looking at the g function, a domain value of 3, which is here, and the ordered pair point y value that goes with it is the number 4, and that will be your final answer. And I'm going to reset all of these, and we'll do the next question. All right, so we start on the inside again. We are going to have f of 0. So I'm looking at an f value of 0, which would be here on the y-axis. And this function hits the y-axis at a y-intercept of 1. So f of 0 is 1, so I have f of 1. And then I'm going to reset that because I'm on the exact same graph because I'm still in f. So for this one, I'm looking at an x value of 1 right there. And we are looking at what y value results, and that resultant y value is up at 4. And that'll be my final answer for this one. And last but not least, we're going to be looking at this last example. And in the last example, we're dealing with g only. So we're going to start with g of 2. So I go up here to 2. And the y value that results in is on the x-axis. So that's a 0. So I have g of 0. And then we've got that we are at an x value of 0, which again is going to be the y-axis here, and it hits the y-axis at the number 2. So that would be my final answer. So you can have those in tables and graphs. Now with these examples, we are not dealing with numerics. All right, you're not doing f composed with g of 7, for example. You're just going to have x's in your solution. So for these, you're going to first see it written as f of g of x, so f composed, it's an open circle. So the first thing I'm going to tell you to always do is rewrite this so that it says f of g of x. And what we're doing from here is taking this and plugging it in where this g of x is. So we're going to have f of 4x squared plus 5. And in the same way that you would do f of 4, for example, you're going to plug all of that in to the f function for the x that's there in the f function. So that means I have 5, and then I'll have x, and then I'll still have my plus 2, and the x that I am plugging in is 4x squared plus 5. And then you'll distribute your 5. So you have 20x squared plus 25 plus 2. And your final answer for this would be 20x squared plus 27. Now, you can do those both ways. This question only asks for one way, so you would type that final answer in. All right, very similar in the next one. However, you have fractions. So my golden rule with this is that you can never leave a fraction in a fraction. So we have f of g of x. We're going to do the exact same thing. So g of x is being substituted into this. So I have f of 5 over x plus 6. And now that I am moving over to the f function, this is going to be substituted in for that x. So I have 1 over x minus 6. So my x is 5 over x plus 6. Now, I'm using the parentheses to simply state that we are plugging that in. They are unnecessary, so I'm going to go back and I'm going to take those out because I don't need them. And what I'm noticing when I do that is that those 6's cancel. So this means I have 1 divided by 5 over x, so I keep it, flip it, and change to multiplication. So that means I'll keep 1 over 1. I will reciprocate 5 over x, which gives me x over 5, and I'm going to multiply straight across. So my final answer that would be typed in online is x over 5. So we're going to reset that problem, and I'm going to be doing it in the opposite direction. So I'm going to erase my shading. This was 5 over x plus 6. So in this case, I'm doing g of f of x. So I'm going to take the f of x function right here, and I'm going to substitute it in here. So this is going to give me g of 1 over x minus 6. And at this point, I'm ready to go substitute this into the g function. So this is going to be substituted in right here. So this will result in 5 divided by 1 over x minus 6. And then we're going to add 6 to this. So what I have to do is, again, I have this compound fraction, so I'm going to keep it, flip it, and change it. So I'm going to keep 5. I'm going to reciprocate 1 over x minus 6, so that gives me x minus 6 over 1. And then I'm going to add 6 to it. So I get 5x minus 30, and I'm going to add 6 to that. So my final answer, and I've run out of room, so I'm going to keep writing over to the side instead of below. So that's going to be 5x minus 24. And that's what you type in online. Next one, we're going to go both directions as well. So this is going to give me f of g of x. My g of x function is 6 over x. And now I'm going to plug that in. This is going to go in for that x as well as that x. And no, those cannot be canceled. So I have 6 over x in the top. I'm going to keep that in parentheses just so I see that it's in the top. I'm going to have 6 over x in the bottom, and then I'm subtracting 7. All right, so this question works a little differently because I can't combine my denominator in any way until I get a common denominator. All right, so I'm going to erase these just so that I can work with this. So I'm going to make this into 7 over 1. And I'm getting a common denominator, so I need to multiply by x over x. So my numerator is going to stay 6 over x. My denominator is going to turn into 6 over x minus 7x over x. And since I now have that common denominator, I keep 6 over x here. I keep 6 minus 7x, and then my denominators are the same, so it stays the same. Then I'm going to insert my parentheses back in here because I'm going to keep it, flip it, and change it to multiplication. So I keep 6 over x. I reciprocate the bottom, so that's going to be x over 6 minus 7x. And I know that those x's will cancel each other, so my final answer that I would type in online is 6 over 6 minus 7x. So now we're going to go the other direction. So I'm going to erase my shading up here. Sorry, that's so bolded, it's not supposed to be. All right, so we're going to have g of f of x. My f of x is x over x minus 7. So all of this is going to go in for that x right there. So I'm going to have 6 over x minus 7. Now the parenthesis just helps me remember that all of that's in my denominator. Now I'm going to keep it, flip it, change it. So I keep 6 over 1. I flip, so this turns into x minus 7 divided by x. And this time nothing's going to cancel. So I have 6x minus 42, and that's divided by x. And that's my final answer because there's no more simplification to do. The next question gives us a radical and a denominator, and then it asks us not for what the compositions are, but for what the domains are. Now, in order to do the domains, I still have to find what they're asking me for. So I know that p of x over h of x is going to give me 1 over the square root of x, and I'm going to divide that by x squared minus 4. So again, I have a fraction in a fraction, so I'm going to keep it, flip it, change it. So I'm going to keep 1 over the square root of x. I'm going to reciprocate x squared minus 4 over 1. So that turns into 1 over x squared minus 4. And when I multiply that, I would simply have a 1 in the numerator, and I would have one factor of the square root of x and another factor, which would factor into x plus 2x minus 2. So to find the domain of this, I know that my denominator cannot be equal to 0. So I have the square root of x times x plus 2 times x minus 2 cannot be equal to 0. That's for the domain of this division of these two functions. So I have 3 factors. So I said the square root of x has to not be equal to 0. I have to have x plus 2 cannot be equal to 0. And I have to know that x minus 2 also cannot be equal to 0. So not only can the square root of x not be equal to 0, which means x can't be 0, okay, I also know that my x has to be greater than 0. It's in a denominator, so it can't be equal to 0, which we just said, and it also has to be greater than 0. So what that means for us is when we look at this number line for the domain, typically we put on there negative infinity to positive, but I'm going to start at 0, and I know that no part of the domain can be on this side of that number line. It's impossible. It cannot be a negative number because that would make imaginaries. So then I'm looking at these other two, and it says x cannot be equal to negative 2. Well, negative 2 would be somewhere over here, so it's already excluded. And then this one says that x cannot be equal to positive 2. So I have to put a 2 on here, and it cannot be equal to 2. So we said from here it can't be equal to 0, so that's a parenthesis. It can't be equal to 2, but that means it can be equal to all of this and all of this. So for this domain, it would go from 0 to 2, union 2 to infinity. No brackets of any kind anywhere. So then we reset for the second part of the question. The second part of the question is talking about the domain of the composition. So for the composition, we're going to have p of h of x. Well, h of x is x squared minus 4. And when I substitute x squared minus 4 in, to the p function, that will go right there. So that means I've got 1 over the square root of x squared minus 4. So again, I have a rational expression, but I also have a radical. So I know that x squared minus 4 cannot be equal to 0. So that means that x cannot be equal to plus and minus 2. All right, we did that up above, so I'm not going to redo it. So it can't be plus or minus 2. But I also know that x squared minus 4 has to be greater than 0. So if I draw my number line and I have negative 2 and positive 2 are on there, then what I need to figure out is where do I shade. So if I look to the left of negative 2, I'm going to have a test value. All right, I'm going to put my test values in red so we don't get them confused. Test value would be negative 3. So if I plug that negative 3 in for this x, what I'm trying to figure out is if it makes a true or a false statement. So if I have negative 3 squared minus 4, all right, that's going to be 9 minus 4, which is a positive 5. Well, this says that I need to be greater than 0, so is 5 greater than 0? Yes, it is. So I'm going to shade that section as part of my domain. Now, if I go, and I know that I can't be equal to 2, so this is a parenthesis. If I'm going between negative 2 and 0, then a good test value would be 0. Well, if I do 0 squared minus 4, 0 squared is 0, and then I still have a negative 4. Is negative 4 greater than 0? No, it isn't, so that is not in my domain. And then all the way to the right, I have a 3. So if I take 3 and I square it and I subtract 4, again, I will get the number 5. And 5 is, in fact, greater than 0. So this is a yes. And I know that I cannot be equal to 2, so this is a parenthesis. So the domain for the composition will go from left to right. So I go negative infinity up to negative 2, parenthesis, and then also, so union, I have 2 to positive infinity over here on the end. So that would be my domain. Now for the last one, we're doing another composition that I'm going to go down since I've written my test values over through there. I have h of 1 over the square root of x. And I want to stop right here because these have inherited domains. So if this is the original function for which I'm putting domains in for that x value, I know that x already has to be greater than 0. It does not matter what else happens at that point, the domain already has this restriction and it can't go anywhere. It's not going to disappear. I have to keep it. So then I'm going to plug this into x squared minus 4. So 1 squared is 1. The square root of x squared is x. And then this is negative 4. So this domain comes down. And when I'm looking at this new equation, it just says that it can't be equal to 0, which was what we already had. We know that it's greater than 0, so it can't be equal to 0. So on our number line, we need the number 0. And we're going to go to the right of that. And there would be my domain that goes from 0 to infinity. You have a word problem on this set of homework that gives you, it's a little scenario that says the demand for a certain product at a price P is given by D of P. So D stands for demand at a given cost, or price. And then C of X is how much it costs for something to be created if you are creating X items. All right, so this has a price of $9. So that would have to go into there. So that would be the demand at $9. And then it wants to know about the cost. So that would be I think it's multiple choice, so that would be the one that you would choose.